Hello everyone, this is Athreya and welcome to our channel CodeChef. Today we're going to be solving the problem attic crossing with the difficulty level of cakewalk. Let's get started. Here it's given that you are given a strings of hashes and dots. So basically your string will look something like this, hashes and dots. Hash represents the presence of a floorboard while a dot represents the absence of it. Now Diggory and Polly decide to cross the passage from left to right, and at each time they can only tell where the next hash position is. They start by being able to jump at a distance 1, and whenever they are unable to jump at a particular distance L, they will spend 1 day to learn how to jump at a distance L. And now if you learn to jump at a distance L, you are able to jump at all distances less than equal to L trivially. For example, if you take 1 day and learn how to jump at distance 3, you also know how to jump at distance 2, so on and so forth, for all values less than equal to this L what you learned. Now, how many days will they be able to cross a passage? So let's reiterate. You start by being able to jump at a distance 1, and whenever you are unable to jump at a particular distance L, you will take 1 day and you will learn how to jump at distance L. Once you learn how to jump at distance L, you can trivially jump at all distances less than equal to L. We need to count how many number of days they take to cross a passage. Let's look at a sample case. Don't worry if this is unclear till now. Now what happens is, for this one here, if you have hash 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 hash, you can directly trivially cross this and you will take 0 days here. However, let's look at this case. This is interesting. When you encounter the first dot here, you need to learn to jump at a distance 2 and you will take 1 day for this. When you encounter dot dot, you need to learn to jump at a distance 3 and you will take 1 day. So totally you took 2 days. How 2 days? In the first day you learned how to jump at a distance 2, and in the second day you learned how to jump at a distance 3. So 2 days. For this is triple 0. You don't have dots here. Now in this case here, what is this? Now since you only know the position of hash, remember that's why we're doing this. You have dot and dot here, which means that in order to jump from this hash to this hash, you need to learn to jump at a distance 3. So you will spend 1 day to learn how to jump at a distance 3. Now you have another dot here at the end. Because you know how to jump at a distance 3, it is very easy to jump from this floorboard to this floorboard at a distance 2. So you spent 1 day and you spent 1 day learning how to jump at a distance 3. Once you already know how to jump at distance 3, you also know how to jump at distances less than equal to 3. Hence, for this last jump from this floorboard to this floorboard at a distance 2, you already know. How you know? Because you spent 1 day learning to jump at distance 3. Now for this fourth test case, from here to here, if you want to jump, you need to learn how to jump at distance 2. So you will spend 1 day learning how to jump at distance 2. Now from here to here, if you want to jump from this floorboard to this floorboard, you need to learn how to jump at a distance 5. Now in order to learn how to jump at distance 5, you will take 1 more day. So you take 2 days here. So you took 0 days in the first test case, 2 days for the second test case, 1 day for the third test case, and 2 days for the fourth test case. Now what is the approach we will take in order to solve this problem? Now the approach we will take is very simple. We will run a loop. So let's say for character in str, where str denotes this string of hash and dots. We only know the position of remember the hashes. Now, if your character equal to hash, what will you do? If your character equal to hash, what you will do is you will check first if your what you require to jump, if that distance is greater than what you currently can jump. Remember that you already start out by learning to jump at distance jump equal to 1. So this is there. Now we will say current equal to 0 and we will keep incrementing our current. Why we are doing this? Now let's process the second test case. Okay, now for this one, now our current will be 1 and our distance also is 1, so we can trivially jump there. We don't even need to update our answer variable. So what we do is this: basically, if our character equal to hash, we will check if our current is greater than jump. If this is satisfied, we will update our jump length. Because we updated our jump length, it means that we spent 1 day learning to jump at current, the value current. Hence, we need to update our variable. But there is something wrong in this pseudocode. Can you pause this for a minute and find out what is wrong with this pseudocode? When our character equal to hash, we need to set back, regardless of whether your current, your jump threshold meets the required value or not. You need to reset current equal to 0. If this is confusing, let's dry run it for this case here. So what this is? So basically what this is let's dry run it for this case. First, we have a hash. So our jump value is 1, current is 0, and our value is hash. Since our value is hash, before that itself our current value became 1. Our current value is 1 and we need to check if we are able to jump at value 1. Yes, our jump value is 1 and we are able to jump at distance 1. No problem. Now we are processing the second character. When we process the second character, our current is reset to 0, and then what happens, our current again became 1. Now you are checking jump with current. Jump and current are both 1. So no problem. Here what happens? Here our character is not basically a hash, but still our current value becomes 2 now. Our current value becomes 2 and our jump equal to 1 after we encounter this dot. Pause this video and hope this part is clear. After we process this, when we process this dot, current is 2 and jump is 1. When current is 2 and jump is 1, we compare current and jump. When we encounter our hash here, basically. When we encounter our hash here, our current is 2 and jump is 1. Since our current is greater than jump, we only know what this means is we only know how to jump at a distance 1. But in order to cross from this floorboard to this floorboard, we need to jump at a distance of current, which is 2. Hence, we need to update our jump value to 2 and we need to increment our answer. Our answer variable counts the number of days, basically. From here to here, in order to learn to jump at a distance 2, you spent 1 day. So answer plus equal to 1. That is what it means. Now what happens is again your current is reset to 0, and when you come to this last hash, basically this means that your current value will be nothing but 5 and your jump value will be nothing but 2. How is the jump value 2? Because you updated it when you process this dot, the next character. Now what happens? Your current is 5 and your jump value is 2. Because your current is 5 and your jump value is 2, in your comparison, if current is greater than jump, it means that you need to learn to jump at a distance current. Hence, you update your new jump value to be 5 and you increment answer, which was already 1 by 1. Hence, your answer becomes 2. So that's what this entails. Now, just so that this is completely clear, let me just take this test case. Let me take this random test case and tell you what this answer will be. Now, what happens is hash is no problem. Now from this hash to this hash, if you want to jump, you need to learn to jump at a distance 4 and your answer will be 1. Now this is no problem. Now let's say there's another hash here. From here to here, if you want to jump, you need to know how to jump at a distance 3. Since you already learned to jump at a distance 4, you also know how to jump at distance 3 and the answer will just be 1. That is why this is necessary to have this condition. Now, why do we need this current condition? We already saw, because if we just increment current without resetting back to 0, current will become 2 here, which is wrong. Current should not be 2 here. Current should be 1 here. That's why. So basically, current keeps track of the distance of the jump we need to make. Jump keeps track of the maximum distance that we can already jump. If the distance that we need to jump is not met by our value in the jump variable, we have to update our jump variable. Hope this is. Now let us look at the code for the approach that we have just discussed. Now what we have discussed in the approach, we have a loop here running through all the characters. Then we check if our current character is hash. If our current character is hash, we check if current is greater than jump. This means that we need to spend 1 day to learn to jump at the value current. Hence, we update our jump to current and we increment our answer by 1. Answer stores a number of days. Now, before that, regardless of whether it's a hash or a dot, we need to update current. Current equal to current plus 1 here. Now, at the end, if we have a hash, we need to re-update our current to be 0 because we have already jumped to the floorboard currently at index I. Hence, we need to re-update our current to be 0. This is exactly what we discussed. Initially, we start out by being able to jump at distance 1 already, and our answer variable is 0, denoting the number of days, and our current will also be 0. Hope this part is clear. This was a C++ code. Let's look at the Python code for the same problem. In the Python code, it's very similar. We input the passage string, which is a string of hashes and dots, where hash denotes the floorboards. We only know the position of hashes. We start out by jumping at distance 1. We already know how to jump at distance 1. Our current equal to 0, answer equal to 0. For every character in the passage, what we do is we update our current to be current plus 1 and we check if it's hash. If it's hash, we check, is it possible to jump to the hash or the floorboard at the index I using the jump value that you already know. The value that we already know is 1 initially, the jump value. We check if current is greater than jump. If current greater than jump is satisfied, it means that we cannot jump to the floorboard using our current jump value, and we update jump as current and increment the number of days by 1. Then we reset back current equal to 0. And then we print the final answer. Hope this is clear. Hey guys, that was it. Thank you so much for watching this video, and if you haven't yet done this, this is a gentle reminder to hit that subscribe button. If you're interested in competitive programming and data structures, this channel is a one-stop solution for you. See you in the next video.